On this problem, step 1 says to isolate the radical. Well, because the radical goes all the way to the equal sign, this is isolated already. Step 2 says raise both sides to the index, and this index happens to be 4. So I'm going to raise both sides to the fourth. The fourth exponent and the fourth index undo each other, which is what we really wanted. So I get x squared plus x minus 4 is equal to 2 times 2 times 2 times 2, which is 16. Then I'm going to, because it's quadratic, notice it's quadratic, I need to set it equal to 0. I think this one factors. X and x, two numbers that multiply to 20 and add to 1. 5 and 4 with a positive on the 5. So that's x plus 5 equals 0 and x minus 4 equals 0. So I think the two answers are -5 and +4 as my two potential answers. Potential because I have to check them. So let's first check x is equal to -5. And then I'll go and check x is equal to 4. So on x is equal to -5, I plug in -5 squared, that's actually +25, plus a -5 minus 4 is supposedly equal to 2. Let's see, that's 25 minus 5 is 20 minus 4 more is 16. Is the fourth root of 16 equal to 2? Well, yes, it is. So let's check 4. The fourth root of 4 squared, well, that's just 16, isn't it? Plus 4 minus 4 is supposedly equal to 2. So it's the fourth root of 16 plus 4 is 20 minus 4 is 16. Well, guess what? That is equal to 2. The fourth root of positive 16 is positive 2. Both of these work out. On our next problem, the radical is on the other side, but that's okay, no problems. We just have to identify if the radical is all by itself, and it is. Great. Step 1 is done. Step 2 says raise both sides to the index, and this little index is 2, so I'm going to raise both sides to the 2. The square and the square undo each other, which is the whole point of this. That gives me 4x plus 15. On the left-hand side, I have 2x times 2x. Be careful, make sure you're squaring both the 2 and the x to get 4x squared. I still have a square, don't I? So I need to use my quadratic skills. I'm going to move the 4x and the 15 to the other side. I use transposition by if I move across the equal sign, they have to change sign. I'm going to try to factor. I'm not sure if it does or not. The factors of 15 are what? 1 and 15, or 3 and 5. So let's see, I'm going to try 2x and 2x. And obviously you could use AC method if you wanted. I'm trying getting 6x and 10x, and I need to get to a -4. That's a negative on the 10, a positive on the 6, and then your signs slip in. So I actually got it on my first try, which is nice and convenient. We have 2x plus 3, 2x minus 5. So I set each of these factors equal to 0. And then solve each of them. 2x is equal to -3. 2x equals +5 on the other one. And then divide everything by 2. So that gets me x is equal to -3 halves and +5 halves as my two potential answers. Still got to check them, don't I? So let's do the check over here. Let's check x is equal to -3 halves first. So 2 times -3 halves, and that's the square root of 4 times -3 halves plus 15. Well, on the left-hand side, the 2's divide out. That's real nice. 4 times negative 3 is negative 12. Negative 12 divided by 2 is negative 6. I should put question marks on these because I'm not sure if they're true. So the square root of 9, is that equal to negative 3? Uh-oh. The square root of 9 is equal to positive 3, so this is not right. Which means x is negative 3 is not a valid answer. Now, I cannot say at this point if the other one is or is not. I have to check it totally independent. So if I take 2 times 5 halves, and that's supposedly equal to the square root of 4 times 5 halves plus 15. The 2's divide out, that's real nice. 4 times 5 is 20, and 20 divided by 2, that's 10. So let's see, 5 is equal to the square root of 20. That is true. Okay, so the 5 halves works, but the negative 3 halves doesn't. That's not our fault. Okay, so the answer is just 5 halves. On this problem, please do not scribble out the negative 3 halves. I want to see it. I want to give you credit for that you got the negative 3 halves. And then I want you to put a clean X through it so that I can see and give you work for all of your points. And I know that you know that's not a valid answer, so you just put a clean X through it. On our next problem, my radical is not yet by itself, so I need to get it by itself by adding 2 to both sides. So that gets me the square root of 3x plus 4 equals x plus 2. Now I need to raise both sides to the index, and this index is 2, so I'm going to square both sides. That undoes the radical, which is what I want. But on the right-hand side, I have a binomial squared. This is the first time I have a binomial squared, which means that I need to write out my two binomials and distribute, which is getting me x squared plus 2x plus 2x plus 4 and then I'm going to subtract 3x from both sides and subtract 4 from both sides, which gets me 0 equals x squared plus 1x. Uh-oh, the 4's add to 0, don't they? Okay, and if you're one of those people that really prefer the 0 to be on the other side, feel free to just erase it and move it. That's okay. So this one can factor. Now, sometimes when it's easy like this, some students are like, oh, what do I do? And they try to make it more complicated. This clearly just has a GCF. That's it. So I'm going to factor GCF out and I get x plus 1. And look at that. It's completely factored. So I set each factor with an x in it equal to 0. And then I solve. I get x equals 0 and x equals negative 1. These are my two potential answers. Clearly I have to still check them. But those are what I think my answers might be. So I'm going to check x is equal to 0 first, and then I'll go and check x equals negative 1. So for the 0, I have 3 times 0 plus 4, take the square root of that, minus 2 is supposedly equal to 0. Okay, so the square root of 4 minus 2, is that 0? Well, 2 minus 2, yep, that's 0. It certainly is, so 0 works. How about the other one? 3 times negative 1 plus 4, then subtract 2 is supposed to be equal to negative 1. So that's negative 3 plus 4, that's 1, positive 1. The square root of 1 minus 2 is negative 1, supposedly. So 1 minus 2, is that negative 1? Yes, it is. They both work. So that was an example where the right-hand side had a binomial and I had to square it. Let's do one of those again because that I find a little tricky whenever you have a binomial squared. So my radical is not yet by itself. I need to subtract x from both sides to get the square root of 30 minus 2x is equal to negative x plus 3. Or you could do 3 minus x. Either way makes you happy. That's fine by me. Step 1 is done because the radical is all by itself. Next, I'd like to raise both sides to the index, and the index is 2, so I'm going to raise both sides to the 2. The square and the square root undo each other, so I have 30 minus 2x is equal to negative x plus 3 squared. Because it's a binomial, I can't just distribute that in my head. That's not going to work. I'm going to miss a middle term. So be sure to write those out and distribute. Negative x times negative x is positive x squared. Negative x times positive 3 is negative 3x. 3 times negative x is negative 3x. And 3 times 3 is positive 9. Let's combine like terms on that right side. These two can add up to mean negative 6x. Then I'm going to move all of my terms to one side. Get one side equal to 0. So I have 0 on that side equals x squared minus 4x minus 21. And if it makes you feel better, it doesn't really matter, but if some people like the 0 on the right hand side, you can move it. Two numbers that multiply to negative 21 and add to negative 4 are going to be 7 and 3, with a minus on the 7, a positive on the 3. Then I'm going to solve each of those linear factors, set them equal to 0, and I'm getting x is equal to 7 and x is equal to negative 3. So those are the two answers I think are the correct answers. But to be sure, I have to go back and check. So let's check x equals 7 first, and then we'll come back down here and check x equals negative 3. So I have the square root of 30 minus 2 times 7 plus 7 is supposedly equal to 3. So 2 times 7, that's 14. 30 minus 14 is square root of 16. And 4 plus 7, is that equal to 3? Oh, no, but if 4 was negative, it would have worked out, which is usually what happens. It's only off by a negative. So that one's not right. Okay, I didn't do anything wrong, but inherent in the process of squaring both sides, sometimes you get a bad answer. How about negative 3? Square root of 30 minus 2 times negative 3 plus a negative 3 is supposedly equal to 3. So we have the square root of 30 plus 6, which is 36. (36) is 6, and 6 minus 3, is that equal to 3? Yes, it is. So this is not no solution. You do have a solution. The x is equal to negative 3, but I want to see your work. I want to see that you know that 7 is not valid, but that you got it as an answer and you excluded it as an extraneous. And that concludes this lesson.